Hello, this is Ahmed Hazim Abdurrahman, and with me is Ahmed Hanafi Mahmoud, and our topic today is going to be about Moore's Law. In the past, specifically 1956, IBM introduced its first IBM 3 and 305 RAMAC, which was the first supercomputer that would feature a hard drive that weighs over a ton, and it could only hold 3.75 megabytes of data by today's standards. You needed a forklift to move it around, and it wasn't really practical if compared with this age's inventions. Nowadays, we have tiny microchips that can hold 17,000 times of data and weigh a lot less. Today, we are in the age of transistors, so switches are too simple on the surface, it's just a switch that says on or off. However, those tiny switches are the basis of the binary language, which opened for us a gateway to many huge and amazing inventions that we use in our daily lives. But due to our rapid development in the field of computer sciences and electricity, Moore's law seems to have flowed. Someone who thought that Moore's law is already breaking down is Michio Kaku, a famous science communicator and expert in the field of theoretical and futuristic physics. But what exactly is Moore's law? It's a theory related to the number of transistors in a computer chip. It says that the number of transistors that can be fit in a computer chip will double every 18 months, resulting in periodic increases in computing power. Well, it's sad to know that we won't continue our rapid development in computer chips with the same pace in the past, but you needn't worry, because Intel um, has already planned countermeasures for the situation. They plan to tweak it a bit with chip-like computer in 3 dimensions. That also means our small computers might need to turn into quantum ones to match Moore's law. Um, According to Kako, in about 10 years or so, we will see the collapse of Moore's law. In fact, we already see a slowing down of Moore's law. Computer power simply cannot maintain its rapid exponential rise using standard silicon technology. So we just need to depend on Intel Corporation that it would actually try to match space with Moore's law, just like how it did in the past. And we needn't really worry about our computers. We don't exactly need to turn into quantum ones, because manufacturers are actually going to provide us with more effective and more developed computer chips as we go on. I think this is my part for the presentation, and now it's my friend's uh, time. Thank you.
Thank you, Ahmed. Hello, everyone. We are going to talk about an introduction to Nevin's law. Nevin's law means that more transistor could be packed into a chip, which drove the exponential growth of computing power, which led to the replacement of Moore's law into Nevin's law. And for your information, Nevin's law is named after Harmut Nevin, the director of Google's Quantum Artificial Intelligence. Now, with investors and the economy, where Moore's law ends here. The technology powering modern computers is getting closer to unbreakable physical limit after applying Nevin's rule. That has already been responsible for a big chunk of the slowdown in the economic growth since 2000. But the situation is poised to get much worse unless the world's chip manufacturers invent an entirely new way to crunch numbers. As for decades, scientists and engineers increased computing power and energy efficiency by shrinking transistors and cramming ever more of them onto microchips. And last with Intel POV, where the co-founder Gordon Moore correctly predicted that the number of transistors that could fit onto a chip would double every 2 years, hence the term Moore's Law. When Moore made this prediction, revising his 1965 forecast that doubting would occur every year, the best chips had transistors that were 6,000 nanometers thick, or about the length of a single red blood cell. And thank you, everyone.